All right, so assignment number 8, we're still talking about systems of inequalities. And so we're going to be graphing systems today, but not systems of equations, systems of inequalities. And so hopefully we did okay on the assignment number 7 where we were just graphing one inequality. Now we're going to be doing several. And so let's take a look at our first example here. It says your parents will be happy if your total tardies plus referrals are 5 or less. So let's start by talking about your tardies. Let's call your tardies X. And so let's just talk about the possible tardies that you could have. You can't have negative tardies. You could have 0 tardies, which would be great. You could have 1, 2, or 3. Your number of tardies is going to be greater than or equal to 0. And then the other thing we're talking about is referrals. And so if we call your referrals Y, your referrals, hopefully you don't have any referrals, but you can't have any negative referrals, which means your referrals have to be greater than or equal to 0. You could have 1, 2, 3, and so on. Hopefully you don't, but you could. So we have 2 equations there. But then it says that if you take your tardies plus your referrals and it's 5 or less, your parents should be happy. So your number of tardies plus your number of referrals, if we add them together, you want that to be 5 or less. In other words, less than or equal to 5. So this is our system of inequalities. And what we're going to do is graph this system over here on the graph to see where we're at. I'm going to graph the first one here in, let's say, orange. And so x is greater than or equal to 0. Well, here's where x is 0. And x is actually going to be 0 anywhere along this vertical line. But where are the x values greater than or equal to 0? Well, it could be 1, 2, 3. In other words, they're going to be everything over here on this half of the graph. That's where my x values are greater than or equal to 0. And so it does include this line because we do have the greater than or equal to sign. And so far we're talking about all of the points on the right-hand side of the graph. Well, then if we take a look at, let's do this green here. If we take a look at y is greater than or equal to 0, here's where y is equal to 0, and actually y is equal to 0 all along this line here. And so it doesn't matter what the x value is, that's where the y values are always going to be 0. It could be 1, 0, 2, 0, 3, 0, 4, 0, or so on. It does include that line because it's greater than or equal to that, but it also is all the y values that are greater than that, which means it could be anything up here. And so right now we know we're talking about the top right-hand corner of the graph. That's the one area that makes not only this equation a true equation, but also this equation a true equation. But then we also want to graph this last equation, and so I'm going to graph this equation, and this is going to be a pretty graph, isn't it? If I have x plus y is less than or equal to 5, I could graph that 2 different ways. I can make an x and y chart and plug in zeros, or I can get this y by itself. Let's say we get the y by itself. I'm going to subtract x from both sides, and then I will have y is less than or equal to negative x plus 5. And if I graph that, I'm going to start right here at 5. The slope is negative 1, so I'm going to go down 1 over 1, down 1 over 1, and all of these points are going to be on the graph. It's going to go through 5 down here also. It is going to be a solid line because I do have less than or equal to, and I would shade everything y is less than that, everything on this side of that purple line. And so the solution to the system, however, is where all 3 parts could be true. And so where on the graph is it shaded 3 times? And so I'm going to go back to let's say this black, and where it's shaded 3 times is this triangle right here. And anything in this triangle here is going to be a solution to my system because all of those points make all 3 of the equations a true equation. And so you might want to use, for your homework assignment, you might want to use different colors of graphs to do your different parts to your system, your different equations to your system. But you also want to make sure that, like here, all of my lines were solid lines because they all had a equal sign underneath it. Sometimes they're going to be a dotted line, which means that the line wouldn't be included, but here they all are included, and my solution is all of the points that are in the black area of the graph. Let's take a look at one more example. We're going to talk about the Indianapolis Colts, and they usually win if two things happen. The first thing is if they score 21 or more points, they usually win. The second thing is that if they have at least twice as many touchdowns as field goals. And so I'm going to let our Y's be touchdowns and our X's be field goals. We know we're going to just say touchdowns are worth 7. Field goals are worth 3. We really know touchdowns are worth 6, and then you have an extra point that makes it 7. But here's what we want. We want a total of 21 or more points. And let's say that they only score touchdowns or field goals. Well, that means that X plus Y, the number of field goals plus the number of touchdowns, actually it's going to be 3 for each field goal, so 3 points for each field goal and 7 points for each touchdown. We know that we want to be at least 21 points. So we want that to be greater than or equal to 21. There's one equation. The other thing that we want is that we want to have at least twice as many touchdowns as we do field goals. So touchdowns are Y, field goals are X. And so if we want to have twice as many of these touchdowns as we do field goals, we're going to have to multiply this times 2. And we still want the touchdowns to be greater than or equal to twice as many field goals. So if we score the number of, let's say we score 1 field goal, we would multiply that by 2, and we would want at least 2 touchdowns. If we score 5 field goals, we'd multiply that by 2, and we want at least 10 touchdowns. This is our system here. And so we're going to, for your systems, we're not going to do a whole lot of applications, but you are going to be expected to graph these like we are here. So what I'm going to do is graph these two equations. I'm going to graph the second one first, and I'm going to graph that one in red. I'm going to graph this equation here. It starts at 0. Because there is no y-intercept, it's like a plus 0 out here, and the slope is up 2 over 1. Up 2 and over 1, and it's going to be a solid line that looks something like this. And I would actually shade y is greater than or equal to that, which means I'm going to shade everything above that, which is somewhere in this area here. Then I'm going to graph the second equation, let's say in green. So I'm going to solve this equation for y. I'm going to subtract 3x from both sides, and I would have 7y is greater than or equal to negative 3x plus 21. And then I'm going to divide everything by 7. And when I do that, I'll have y is greater than or equal to negative 3/7 x plus 3. And so when I graph this equation, I'm going to start at 3, which is here, and the slope is down 3 and over 1. Down 3 and over 1, and it's a solid line also. It's going to look something like this. And because its y is greater than, I'm going to shade above this line, which is everything in this area of the graph. And so then what I want to do is figure out where is it shaded twice. And I'm going to use a different color. Where it's shaded twice is everything in this area here. And that's going to be my solution to this system, is anything that's in this area here would give the Colts a really good opportunity to win a game that they are in. And so we could have 1 field goal and 4 touchdowns, 2 field goals and 6 touchdowns. All of those would be solutions to this system. So that's what we're going to be working on for our homework, not only today but also tomorrow. And we're getting ready for our final test here this second semester. Good luck with this homework assignment, and we will see you tomorrow in class.